Alright, so this week's lab is the magnetic fluid lab. The purpose behind this lab is to demonstrate the magnetic fluid showing both liquidity and paramagnetism, which makes a great quantity for engineering applications to become possible. Another name for the fluid used in this lab is called ferrofluids. So they are actually used within loudspeakers, computer hard drives, rotating shaft motors, and contrasting agents for MRIs. For this lab, we will need rare earth magnets, ink toner, and vegetable oil. In my case, I was unable to find the correct toner, which I think led to the experiment not being successful, but I later saw that they actually do sell ferrofluid for this actual experiment to be successful. The term ferrofluid is actually a blend of ferromagnetic particles and fluid that is used to describe a fluid that is strongly magnetized by a magnetic field. This occurs because the fluid is composed of tiny magnetic particles up to 100 times smaller than the wavelength of visible light. The most common minerals used in making these magnetic particles are magnetite and hematite. Those tiny particles are then suspended in a liquid carrier fluid, which can be water or an organic solvent. Thus, the ferrofluids can be termed colloidal liquids, as they contain evenly dispersed microscopic particles in another substance. Once a magnetic field is applied to a ferrofluid, the nanoparticles are attached and pulled the entire liquid towards the magnetic field. Aside from being used to create stunning sculptures, ferrofluid also has exciting real-world applications. A major benefit of ferrofluid is that the liquid can be forced to flow via the positioning and strength of the magnetic field, and so the ferrofluid can be positioned very exactly. Ferrofluids also have the capability of reducing friction, making them useful in a variety of electromagnetic and transportation applications. An example as to how ferrofluids can be used is in hydraulic suspension pistons, with the strength of magnetic field allowing the suspension to be hard and soft depending on what is necessary. It can also be used as a liquid seal in many electronic devices. In computer hard drives, ferrofluid can be used to form a seal around the rotating shaft. It can also aid in the use of loudspeakers to improve performance. Ferrofluids can also be used to keep us safe. New body armor is being developed by MIT, which utilizes ferrofluid in hollow fibers. This body armor could act as an artificial splint in the heat of battle. Currently, research on using ferrofluids to create an artificial heart with no mechanical parts is being undertaken by Suprock Technologies. By surrounding the heart with magnets, the ferrofluid fixed to the frame of the heart will expand and contract when needed, imitating the pumping of the real thing. If developed correctly, this system may be a better option than current heart assist devices because they do not have moving parts, meaning that there will be less stress on the heart and they will also be cheaper. Now I'm going to be demonstrating how I did this experiment, and as I stated previously, I don't think I purchased the correct toner that was specified, but also knowing now that I could perform this experiment again with the correct ferrofluid, I think it would work a lot better. As you can see, I am adding the ink to the vegetable oil that was at the bottom of that container and trying to stir it together to create one thinner liquid. And then I am attaching the rare earth metal to the side of it to see if I'm creating any spikes within the liquid for the magnetizing portion to occur, and unfortunately it did not, but now that I know for the future on how to successfully do this experiment.